Hi, this is Owen Astracan on April 8th, 2024, talking about peer-to-peer for Compsci 342. As a reminder, I'm not there in person. Where am I? I described this in class briefly last week, that I'm in the city whose landmarks you see in the top right, the Golden Gate Bridge and the Salesforce building. And I've just finished, as you see this, a day in a courtroom with Judge Alsop for a case involving Splunk, a company recently purchased by Cisco for some money. As a reminder about what other companies have been purchased and how they might have helped change the landscape of how the internet works, eBay bought PayPal in 2002 for $1.5 billion. Google bought YouTube in 2006 for $1.65 billion. Google bought DoubleClick, an advertising company, in 2008 for $3.1 billion. And Facebook bought Instagram for $1 billion in 2012 and WhatsApp for $19 billion 2 years later. All these purchased companies generate a considerable amount of revenue for their parent companies. First, some administrivia. What's happening in 342? Two things are due today, AB 9, which is the Wikipedia update, and then your reviews for your public policy memo. The final policy memo will be up soon on Perceptive. AB 10 is due on 4/15, that's a week from today, and AB 11 is due on 4/22, reminder, that counts as 1.5 ABABs. Project Phase 2 summary is due in a week. That's the executive summary, and I'll say more about this at the end of class. The details are in the project document. It's 3% of your final course grade for meeting the minimal effort threshold, which is not extensive, but will help you in ensuring that your final project is done appropriately and on time. The topic of today is peer-to-peer architecture and how that's changed the technical and social foundations of the internet, the very topics that this course is about. As a reminder, we've already discussed Netflix, which uses a client-server architecture. The server provides the content, the client consumes the content. Those are fundamentally different roles, and they're fundamentally different systems. The client-server architecture with Netflix is reasonably complex, in part because there's so many clients. You have a smart TV that has a Netflix client. You can watch Netflix on your mobile phone, which moves around. Web browsers on your desktop or laptop. These are all different in terms of the security that's required to ensure that they work correctly and securely, the processing power that they begin. For example, the processor in a smart TV is much less powerful than the processor on your laptop or in your mobile phone. All these clients have different energy, storage, and requirements for keeping the software up to date. Those are the clients in the client-server architecture. The servers, as we've seen, use a content distribution network with a Netflix appliance. Netflix is partially in the cloud with AWS. So this overall architecture is quite complex, even though it's described as simply a client-server architecture. That's for streaming video. Today, the canonical application for peer-to-peer, which is going to be in contrast to client-server, is blockchain. It's decentralized. There's no central server. With Netflix, those appliances were centralized, even though there are many of them. Just as with other content distribution networks that we've studied, you must use that content distribution network, which has a central role in how it works. But with blockchain, the nodes in a blockchain network work both as a client and a server. They can update a block or the file. They can send a file trying to put it into the blockchain network, and they can receive an updated block. So that's a very different application, and there's no central location for getting information about blockchain. That brings us to some of the precursors for Netflix. which today distributes video via streaming. We'll contrast that a little bit with Spotify, which is largely an audio streaming service. In 1999, Sean Fanning, you can see here on the cover of Time magazine, created Napster. He was leveraging the MP3 format for audio, which was new at the time. He was leveraging what we'll see as a hybrid peer-to-peer architecture. He was leveraging college students who typically enjoy free or inexpensive costs. And he was leveraging the beginning of the new millennium, 1999. He was a student at Northeastern and created Napster so that his friends, and then ultimately everybody in the world, would be able to stream individual tracks on different CDs. Before there was Napster, you bought music on a CD, which had largely replaced vinyl at the time. But you bought the entire CD. You couldn't buy a single track. Later, Apple and iTunes would create the possibilities for downloading individual tracks, but Sean Fanning arguably changed the entire landscape for how music was marketed. We've already seen that Sean Fanning was a student at Northeastern, and he collaborated with co-founders from Silicon Valley in creating the Napster company. We can see here in the diagram that there is a central server, a central index server in the middle of the diagram. Users would need to connect to that to find out where files were located. Files meaning individual files for a specific track on a CD for a particular musical artist. Once you found the location of such a track, the file that stored that track, you would download it from an individual user. So in that aspect, it was peer-to-peer because all these clients were also the source of where you got the information from. So a Napster client allowed you to play the music. You were a consumer or a client, but it also served that track to other users on the network. So it wasn't completely decentralized because that central server was where you found out where a track might be located. And obviously those tracks might be located on many different computers. So Napster would try to find you one that made it easy, perhaps close, perhaps because it had a good network connection to allow you to download it. A true peer-to-peer file sharing network would not have a centralized controller. It would be more like the blockchain networks that we previously looked at. One such example of a competitor to Napster was the Gnutella protocol and code base that was used by LimeWire to create a truly peer-to-peer and distributed network. This was a Java-based program that was shut down by the Recording Industry Association of America in 2010. At that time, in the mid-2000s to the late 2000s, the Recording Industry Association of America went to bat and backed up its clients who were musicians and recording industry more so than musicians, and would prosecute college students who were using Gnutella and LimeWire to download content that they did not have the right to download. They had not purchased it, but it was available for free. So the RIAA largely shut down Gnutella and LimeWire. And on the right on this picture, you see the engineer at LimeWire, Ernie Yu, who ultimately pulled the plug. According to Ernie's LinkedIn profile, he's been an engineer at Spotify for more than 10 years. So when LimeWire shut down, Ernie brought his programming and organizational skills to Spotify. Perhaps, and not even perhaps, totally coincidentally, on your left, you see a picture of Ernie Yu in the middle, smiling during a math exam in his senior year, and the student to his right, who looks as though he's concentrating immensely on his math exam, might be, oh, I don't know, Owen Astrachan. So Ernie was a high school student with me, who is still a software engineer, and I keep in touch with him. That leads us from LimeWire and Gnutella to BitTorrent, a protocol designed by Bram Cohen, another young software engineer, that was used for true peer-to-peer file sharing. Client programs implemented the protocol. So the protocol was essentially the algorithm, what we might call today an API, the method by which BitTorrent worked. And Bram Cohen also created an initial implementation of this protocol. At first, there was some centralization where clients had to find a torrent file and then a seed to find out where the content was. But the content was not in one place. That was the ingenious part of BitTorrent. Unlike Gnutella and Napster, which stored the entire MP3 file in one place, whether that was on another client's computer or in a server, in BitTorrent, the file was broken into pieces and it was spread throughout the internet. When you went to find one, that torrent file would tell you where to start finding it, and then as you began to download pieces of it, other files on other computers would also be downloaded, and together they would be put together onto your machine if you wanted the entire file. And there was an incentive so that if you shared more from your own computer, that means that you allowed material to be uploaded, you would then be allowed to download faster. And mostly people wanted fast downloads, and so you would likely allow an upload. So the whole protocol was designed to ensure that the entire community of torrent users were cooperating in some sense. In the early to mid 2000s, as we can see here in 2004, according to many sources, more than 30% of all internet traffic was torrent traffic, largely pirated software and pirated movie and audio content. At that time, there were no streaming services. The internet was much slower than it is today, and payment was complicated. As it says here, there was lots of pirated traffic. Ultimately, BitTorrent was also used for legal purposes. In fact, today, although streaming services have largely replaced that use of BitTorrent, the BitTorrent protocol and BitTorrent clients that realize that protocol are still used to distribute Linux and World of Warcraft software, which is large. And so rather than having a server that downloads the entire software, BitTorrent allows pieces of it to be downloaded from different parts of the torrent network. That brings us to the first WOTO, where you're going to be asked to investigate both Napster-like networks and Napster itself, particularly a service run by a Duke student who ultimately would become president of DSG, Elliot Wolf, and you'll see an article in the Chronicle about him. At this point, we're going to pause for 10 minutes while you complete this WOTO. So the video will resume 10 minutes from now. You're not going to see me. It's going to be paused. All right, as we come back from completing that WOTO, I hope you had the opportunity to read about both Elliot Wolf and then how at least one article talks about how Napster revolutionized the music industry. Let me turn briefly to Project Phase 2. That's an executive summary where you have an outline of what you're going to do. References and the type and quantity of those references are outlined in the project document, and that's due on April 14th. It's accepted through April 15th. That's a week from today as you see this. You'll also be asked to complete a reflection on the first week of work and any issues that you've experienced about working in your group. That will be done outside of Perceptive via a form that you'll receive, and completing that form will be worth 1%, a third of the 3% of the course grade that this executive summary is worth. Again, you'll meet a minimal effort threshold, which is reasonably straightforward to reach as part of making this 3%. The rest of class is in some ways optional, but you're encouraged to use this WOTO, which is the reading quiz for this week. So since you're here, and here might be in Griffith watching this video, or it might be elsewhere watching the video, you can complete the reading quiz, which will be announced after class via a Canvas announcement. And again, it must be completed before class on Wednesday, like all reading quizzes. And so the hope is that you'll use this time in class with your peers as part of a peer-to-peer network, if you would, to complete the reading quiz. I will see you again on Wednesday. Enjoy this day. Thank you.